Okay, so welcome everyone to the webinar 17 of Incose Latam. This webinar, we have the pleasure to have our colleagues joining from France, Cécile and Sebag, and they will introduce the CESAM framework for our community. So we'll skip the abstract because they will provide much more detail about this in their presentation, but we'll introduce Cécile and Sebag. So Cécile Beisac graduated from Central Nantes and the Universitat Politécnica de Catalunya with a focus in energy and environmental technologies. With over 20 years of experience, including 10 years at Veolia, managing large-scale projects. She supports major players in the energy, aerospace, defense, and transportation sectors on MBSE implementation, use of the CESAM framework, enterprise transformation, and product line engineering. She is in charge of the CESAM Academy, promoting best practices in system architecture and driving pedagogical innovation. And our second speaker is Sebag Aynehian, an expert system architect. He graduated in mechanical engineering from École Polytechnique and Imperial College London. He worked 10 years at Safran Landing Systems, including as a design team leader and transformation product leader to turn engineering into a learning organization. Since 2018, he has supported major customers, including Airbus, Safran, NVIDIA, Stellantis, RATP, on MBSE implementation, engineering transformation, and system architecture upskilling. Sebag is also responsible for CESAM's product development, including continuous improvement, internal upskilling, and support for tailoring an application. So with that, I will give the floor to our speakers, and we look forward to your presentation.
Thank you very much.
Thank you for the introduction. So sharing just a sec. That should be it. Yep, Cécile?
Now we can see it.
Okay.
Perfect.
Okay, good. So we are going to talk about CESAM framework. The subtitle is From Complexity to Clarity. And you will understand why after presenting what is the framework and the use of it and its industrial application. So if we move to the agenda of this presentation, I will begin by introducing CESAM, who we are, why we are qualified to speak about system engineering, system architecture, and model-based system engineering in particular. Okay. Then I will let the floor to Sebag, and he will introduce to you what is an architecture framework, what are the benefits of using one, before diving into the details of the CESAM framework, let's say, okay, and its industrial applications. And finally, I will conclude by providing you some concrete action to perform in order for you to be able to implement, starting tomorrow after this webinar, the implementation of CESAM framework in your day-to-day activities. Okay, so let's begin. Let me briefly introduce CESAM Group. Okay, we are a spin-off where we were created in 2011 as a spin-off of École Polytechnique. Okay, we are specialized in the engineering and architecture of complex systems, and by that we mean industrial products, but also information systems and organizational systems. And our core expertise is built around five main areas, which are system architecture, model-based system engineering, but also enterprise architecture, which is system architecture applied to enterprise, okay? Product line architecture, in order to manage the viability of the architectures, and then agility and architecture, to see how to implement agility by doing architecture. So these are complementary disciplines which allow us to address a wide range of industrial and organizational changes. And then to support our clients, we offer a complete portfolio of services, from consulting to training and coaching, but also engineering services. And that ensures an operational support at every stage of either a transformation or project lifecycle. So today, CESAM counts 40 collaborators and coaches, and we are based in Paris, Toulouse, and Lyon, 3 French cities. So beyond our consulting, training, coaching, and engineering services activity, we actually contribute to system engineering community. Okay, we manage a community called CESAM community, gathering system architects worldwide, and have trained or certified around 10,000 professionals in the CESAM methodology to date, maybe more tomorrow. We also organize major industry events, such as the CSDM in Paris or Beijing, Enterprise Architecture Day, thematic conference, and so on. And on social media, we have a LinkedIn community, which now gather over 18,000 followers. And finally, we are proud to work alongside key partners, Inglés, maybe you know that one, and also Dassault System and Vulcan Engineering.
Oops.
So let's now have a look at a selection of our main customer, organized here by industrial domains. So we work extensively in aeronautics, supporting major players such as Airbus, Safran, Liebherr in aerospace, Airbus helicopters, and so on. In the defense and space sector, we collaborate with organizations like Ariane Group, Safran Electronic and Defense, Sodern, Maya Space, which is a startup, an emanation from Ariane Group, sorry, I think. We are also active in the rail, working with SNCF, Réseau, RATP, Alstom, and so on. And in automotive, we support companies such as the Groupe Renault, Stellantis, Valeo. But our expertise also extend to energy and distribution with EDF, Framatome, but also Schneider Electric, but maybe you know more. We also operate in construction and infrastructure, electronics, telecom, and robotics, and so on and so on. So the diversity of sectors illustrates our ability to address complex system challenges, I think, across a wide range of industries. So that was a presentation of who we are. And now I'll let the floor to Sevag to introduce you what is the system architecture framework and the fundamentals of CESAM framework.
Thank you, Cécile. So yes, we've applied, let's say we've worked with so many different customers. Everyone will say, we are different, I am different, but still we have a framework that is tailorable. And that's the reason why we are able to address such a wide range of industries, let's say, with the system approach. So before introducing a framework, I would like to first maybe give a definition for systems architecture. And to come to that, we start from the systems approach. It's a slide we like to show this, let's say, inclusivity. So you may be aware that systems approach is an approach that applies in any field, biology, whatever, anything that you want to study. If you want to study it in a holistic way, 360 way, trying to understand all the dependencies, dimensions, to really feel, to really understand, let's say, kind of deeply, then you're applying the systems approach. And if you apply it to the development of a complex system from a company, let's say, you apply it to engineering, then it becomes systems engineering, the application of the approach to engineering, which makes the engineering a bit different. You have activities that are the translation of that systems approach applied, like configuration management, like requirement management, etc. And inside systems engineering, that's where you find systems architecture. We could call the core activity a central activity that guides all the others by providing the model of the system in a structured way that, you know, aligns the teams and able to clarify what needs to be done. So those three notions of approach, engineering, and architecture are a continuum The approach is the mindset, you know, wanting to understand the 360-degree, let's say, anything, any problem, any scope. The engineering is the application of that to practicing into for development. And the architecture is like the backbone that structures the application in engineering in some way. So that's the first thing we want to present before jumping gradually into a framework. So let's take the example of Paris. I'm not going to ask you if you've been there or not, but let's say it's quite a complex city, like a lot of other cities, like Mexico, obviously. So let's say we take real Paris and you want to visit Paris, and someone who wants to visit Paris cannot, you know, just look at this and know what to do. So he needs, at different moments, he will need different views, different representation. The first one can be, what do I want to visit? So I'm not going to look in the center. I'm going to look at a view that is places to visit, which clarifies the places to visit. Then maybe I want to know how far I am. So I may need the street view that shows me the street of Paris and can calculate distances. But then I need to wonder if I'm going to go with transportation or maybe with my bicycle or with a car. And so I need another view that will provide another type of information. So here we are looking at the complex system, Paris, through several views. And that's the principle that will lead us to a framework that says, if you have a complex system, you need multiple representation. You cannot represent all that we have here on one view, otherwise you just don't understand anything. And then we have those views, but you know, maybe someone will ask a view about the trees, about the temperature, a view about anything, and you're like, okay, we need to limit the number of views, otherwise everyone will describe something different. And that's where emerges the notion of a framework, saying, okay, we have a lot of things we can represent, but let's structure that. Let's define the different views. Let's define their content with the same understanding. What is a tree? You know, I want a tree. What does it mean to have a tree? What is a street? What is I don't know, a pavement? All those are, you know, not ambiguous. They are very well defined, so you can make those views. And so to limit the number of views, and so for everyone to understand them the same way, then that's the mission of a framework. A framework will provide the convention, the rules to describe a system, saying what we describe and what are the views to describe the system in a clear and unambiguous way. That's a simple way to introduce a framework. A framework, now it's born, it tells you how to describe a system. We need to be aware that a framework is one of the 4 pillars to apply correctly model-based systems engineering, which is the application of modeling for systems engineering. And at CESAM, we like to see it not only of 3 pillars, but indeed of 4 pillars, if you've already looked at this topic. So the framework that we just introduced are obviously necessary to know what you put in a model, what views are in the model, how you connect the views. So here we show a few examples, the CESAM framework, obviously, which is the topic of today, but you also have the NAF framework, you have other frameworks, we just quoted a few here. You need also a method, how I'm going to model those views. How do I build these views? What are the steps? Who do we need? What are the inputs? What are the sequence of work? If we are talking about a model, there's necessarily a language. So what's the modeling language? And obviously, what are the tools for system modeling in this case? And every time you see some examples. And it's really key to start from the framework. That's why you see this arrow. I start from the framework and I go gradually to the tool. Obviously, in a company, you have existing tools, but that's just to show the logics of thinking. To have a good, strong foundation, you need to know the framework and you need to have one. Okay, that was really a quick introduction to what is a system architecture framework, because we have already that time. Obviously, there's many more resources, and you'll see that in chapter 4 that you can dig and learn more about those. So now, one of those frameworks is CESAM, for the CESAM architecture method. That's the name of our framework. And I'm going to now introduce it again, the essentials that you need to know. So the first thing you need to know is that the CESAM framework is made of 3 layers that are all necessary and, let's say, fundamentally complementary to each other. If we make it quickly, the first layer is called the operational layer, and it's it is here, sorry, to study the why of the system. Why do we need this system? What are the constraints? What are the services that it's going to provide? To who? When? For what need? So before even that the system exists, you need to study outside of the system. The second layer answers the question, what? What is the system going to do? Okay. Then that's where you introduce the notion of function, which is just about what the system does. And you see already those arrows here that connect the functions to the missions, to everything you've analyzed in the operational layer. You have function because you have a mission and services to provide. But here we're not talking yet about components, because that's what we do in the third layer, the how. Now that I know why I need this system, what it needs to do, now how am I going to achieve it? So what are the resources that the system needs to have and integrate in order to deliver the function that then deliver the mission? And the resources are classically concrete material, hardware, software. Software code is a resource, obviously, or I mean, not obviously, but I need to say, and even people, because systems, CESAM is a system with people inside. We are a company. I hope we are not too complex, but we have people inside. So if your system embeds people, an enterprise typically has people. Okay, you need to understand why I study the outside, what I study the behavior, the functions, and how I really study the components, the structure of the system. Now I'm going to give you a bit more overview of each of the layer, because here it's really the introduction. So let's have a quick look at an operational layer. So as I said, the operational layer is here to study the mission. It's really from an external perspective. We could say that the system is a black box because we are not looking inside, and we really want to understand the outside of the system. So we are looking. Here, I'm not looking at the toothbrush. I'm looking at the teeth. I'm looking at how the people feel, the shape of the hand, the shape of the mouth. I'm not yet looking at the toothbrush. I'm really looking outside. And the outputs we're going to find in this are environment, stakeholder needs, external interface, etc. Those are the concepts that we are going to deliver, study in this layer. And here you have a couple examples for that toothbrush. So someone wants to clean teeth. The dentist wants to improve the teeth cleaning of their patients. End user want to have a good hygiene by brushing their teeth having less than one cavity per year. That's a random need, that we could write. Here we're not talking about the toothbrush. We are really talking about the outside. And here you have one of the fundamental view, which is called the environment diagram here, where in the center you see the toothbrush in this case, and outside you see all the external systems. So here we have the end users, we have IT because it's a connected toothbrush. We have organizations that regulate the health sector, health system, places of use, etc. So here we represent the outside. You see the toothbrush is a black box, and in this example, we've modeled that in the Rhapsody tool, just also to show that that CESAM can be implemented in any tool. So you have different tools here. So that's one of the central diagram of the operational layer. In the functional layer, now we don't study the component yet, as I said. We study the functions of the system. We could say the system is a gray box because it's still a bit black because we're not looking at the components, but it's not white. Oh, sorry, and it's it's a mix of white and black in some way. So here we want to understand architects how the system behaves, rotation, this kind of behavior. We're not looking yet at the actual toothbrush. We know that maybe it's going to rotate, maybe it's going to apply load, whatever, but not yet the solutions. So here we talk about function mostly, flows, modes, requirements, breakdown. And you have a few examples of function for the toothbrush. So let's say you've analyzed and you say, okay, we need a control and command function. We need to provide force because it's the core reason of the toothbrush. Those are examples of function things that the toothbrush needs to do. And associated to those functions, we're going to have requirements, which are, let's say, the performance. How well, what is the level of force? What is the frequency of update? What is all this kind of performance that are going to be associated. And here you have a key diagram, which is the functional interaction diagram that shows the functions and the flows that they exchange. So for instance, provide brushing force will send a force, brushing measurements to the supervised brushing function. Okay, this is just a zoom on one part of that diagram, modeled in Enterprise Architect, and very key to understand the logics of the behavior of the toothbrush, part of the functional layer. Third layer, the constructional layer. Now, finally, if I could say, we say that for joking, we can finally define the components of the system. We could say we are looking inside, so it's a white box. But those components are here because they implement the functions. Remember, we have the arrows between the functional and the core constructional layers. And so we give a reason for those components by allocating them functions. So here we look at the functions and the components, and also at structural performance, let's say, the weight, the dimension, everything that is concrete that also needs to be fulfilled by the components. There's some keywords again, product breakdown, structure, building block, and a couple of examples for the toothbrush. For instance, the toothbrush will declare that it needs a body, a brushing head, a software, an application because it's connected, and example of constructional requirements, which can be the weight, let's say, of the toothbrush in this case. But of course, other requirements will be applied. Yes, we'll answer that question. Okay, I can almost say yes, but let's look. One key diagram, we have the product breakdown, which is key, and the constructional interaction is, let's say, the mirror in some way of the functional interaction. But now we look at components, and that really enables to understand the scope. You know, that component has those interfaces, and it's developed by whatever team, so they know exactly what they have to develop in some way. And in this case, it's modeled in Xatis, which is a recent tool developed by the Saffron group, and that embeds, by the way, the CESAM framework inside. So here, and yeah, finally, to show that it's not only 3 views, you know, we showed you the 3 layers, but indeed in each layer, let's say the magic or the simplicity of the CESAM framework lies in the fact that I already told you, you know, we analyze the environment, we analyze the behavior, we analyze the structure, but inside each layer, we describe exactly the same thing. We describe properties, states, static elements. So I'm not going to give you the detail today, but once you've understood what each aspect means, and you've understood what each layer means, then you can redemonstrate, you can rededuce each view as the intersection of an aspect and a layer. So when you understand that, you really have a logic, a mathematical rigor also to understand each view and know what it should have. So it makes the CESAM framework at scale because people don't need to learn so many concepts. They don't need to know the difference between need and a constraint, the functional requirement and the non-functional. There's really concept that we get rid of for people to focus on what's essential. Okay. So let's go now on industrial application to understand what we've applied and what can be applied, what are the benefits in real industrial context. The first thing is about modeling in tools. So we quoted enterprise architecture, Rhapsody, any other tool. The difference when you have a framework, and we've seen many customers who are not aware and they try to build a framework because they see something is missing, is that you could see the framework as an intention. You know, you are people in the room, you are engineers, you know what you want to do to understand the system complexity independently from tools. You know what your job is in some way of architecture. And you take that intention, you learn it, and you really have it in your blood and nerves. And then you say, okay, I master what I want to do, and now I need to do it in a certain tool. And you can do it, and we've done it with all the tools that are quoted here. Whatever the language, if it's SysML or if it's another language, we do a mapping of the framework and of the modeling language concepts, and we are able to represent CESAM framework in all the tools that are quoted here. And the benefit of having this on the left is that the intention is stable. The tools change, They have new versions. CSML will also change very soon. We're not far from that, but you've still learned what you want to do, and you will know how to do it in a different way. And that's quite efficient. That's about tooling. Now it's about people. CESAM framework is also used. It's a language. It has concept, definition, relation. Some people can call that an ontology, a metamodel. However, it's a dictionary. It's anything. It's a language for people to understand each other. So I'd just like to show this, very simple example. Let's say you are a company, different teams in different countries. I've been working I've been not struggling, but I've learned a lot from a mission on that. And you have a team that works with Rhapsody. You have another team that works with Capella, and another one is, learning Katia Magic. And everyone has, has an experience, a different way of doing system engineering. The CSML guide, the COSI handbook, ISO 15288. All those that's their background, and they're working in different tools. And let's say that one team is going to say, okay, to do the functional, well, we need to model functional blocks, we need to do activity diagrams, and we need a satisfied relationship with the requirements on that diagram. But then the Katia Magic people say, but no, but guys, you need to follow the functional analysis of ISO 15288 and requirements. They're not an artifact. And the Capella people will say, but where are your logical functions? And you need a specific viewpoint. And no, we don't do activity diagrams. And you're like, do we understand each other? I'm right, they're wrong. There are various ways basically to name the same concept. There are various definitions behind the same name. And the framework is really a way to unify. So of course, people have to learn it. And it was hard, but now we speak the same language. And let's say that we are all doing functional architecture. We know what a function is. It's an input-output transformation. We could say it's y equals f of x in mathematical terms. And okay, then logical system, whatever, functional block are different ways of representing. But we all agree on that. And now we can work together and not waste a lot of time on who is right on what concept. And this is really something we observe. A couple of more slides. So just to let you know, the framework is recursive. There is a well-defined handover of artifact from, let's say, system level artifact to subsystem level artifact. So we train on that, and it enables to optimize the number of artifacts and and know where teams need to collaborate at different levels. How do they join? So that the modeling effort is reduced to the minimum, so people can really talk about the content and not about modeling things in some way. And finally, that's really almost the first thing we say at each training, is that the CESAM framework is a toolbox. You need to know what tools to use, but it's also a way to analyze everything around you. Now everything I see, I wonder if it's operational or functional. I'm kidding, but it's kind of becomes a way. It's really a mindset at some point. So let's say that you have any company has a different context. We talk about automotive, aeronautics, energy, and even them have, of course, different contexts. And for instance, what is the context? It's complex, but let's say a context is the frameworks that are applicable. The customer maybe has a framework, the teams inside the company has different frameworks. So this is really important. But also when you develop a system, you wonder if it's a new system, or if it's an evolution of an existing system, if it's a new variant in a product line, if it's a system that will incrementally evolve. So this is really important. It's quite different in every situation. You have challenges, particular technical challenges, I could say, a particularly challenging performance that you've never met, challenging delay, you need to be very quick. Your customer is not mature or is very mature. All that will change and the way you will work. And finally, the tool chain, we've already mentioned, but the tool is an important point. And what we say is that the framework, once you know those concepts, you're unable to map all these context elements with your gridding, with your grid analysis grid, and deduce something like, okay, I think we need to work on that views as a priority. We need to study those components first because, okay, no problem on that one. We need to focus there. We need to be very mature on that aspect, but that one is fine. And we need to use the views for specific use in the project, gates, discipline alignment, decisions. And this really, at some point, becomes a tool, an extension. recordings. Oh, okay. That meant that I need to stop, right? Okay, hand over, Cécile, to you. You're on mute.
Okay, sorry,
Yeah.
I was answering to the questions in the chat. So now let's wrap it up with some action for you. So where should I begin if I want to implement the CESAM framework? So first, you have access to a range of resources, including, as it is shown here, CESAM Pocket Guide, which provides a detailed overview of the CESAM framework. And so it's available for free download on our website. And you can, of course, have the access to the link. We will share the link with you at the end of this webinar. So Sebag is showing to you the Pocket Guide and what it looks like. So that's the first resource you can download. And then a second one you can also download for free is our takeaway material. And for that, we have two formats. One, which is an infographic version designed for use in presentations, if you want to present to other people what is the CESAM framework, for example. And the other is more a compilation of all our key takeaways organized by theme, with one page dedicated to each theme. And so in one page, you have all the major concepts explained, all the view you are going to produce, like the key concepts, the key principles, but also you have practical feedbacks and lessons learned from our clients on the application of the CESAM framework with the key points, for example. So once you have read the Pocket Guide, you can download the takeaways. Could be a reminder on your desk. So step by step, you can download the free resources. Then if you want, you can join on LinkedIn the CESAM community in order to share with other people about your practices and be aware of the events that we organize. And then with that, you can start to course and practice, but training if you want. So let me show you our training catalog, just for you to have an idea of what kind of training we provide. So our training courses cover all the MBSE life cycle, all the population and all the maturity levels, and they are all in English and they can be provided online, okay? So of course, we have first how to raise awareness in the system approach if you know nothing and just want to increase awareness of the people about what it is. Then we have material for mastering system engineering fundamentals at the CESAM framework, but also how to implement this framework in other, with links with other frameworks such as NAF or Arcadia and so on. And then we have how to implement system engineering in a tool, in a dedicated tool, Capella, Rhapsody, and other tools, okay? But maybe you want to develop a specific skill, how to, I don't know, increase your collaborative skills, for example. And then if you want, you can use architecture to meet your special challenges, such as maybe product line or agility, as we have mentioned. And if you're already mastering, we can support you through advanced practices with more high-level certifications and support. And here you've got the details. I will not enter into the details, it will be too long. You can refer to this catalog online. You have a QR code here. It's all on our website. And if you have any question, you can contact me through the CESAM Academy. Here are the email of the Academy. So do not hesitate to ask more documentation if needed, but on any of this training. So that's all for us for today. know if you have questions. We are here to answer you. I have started
All right.
on the queue.
Perfect. So thank you very much for the presentation, Cecilia and Sebag. So we have several questions. Some of them has been put in the chat and others in the Q&A section. So I will start from the Q&A. And I believe the first one was already answered in the chat. Is the environment diagram not the same as the context diagram? And I think the answer was posted by Cecilia in the chat. So I will move forward to.
Okay.
Cecile, you want to add something?
No, I do not want to add anything. I would have repeated what I've already written in the chat. So let's move on.
Okay, perfect. So the next one from John Wade, is the CESAM framework agnostic with respect to the approaches of functional decomposition and object orientation?
So maybe on this one, I'm just opening the chat, so it's not been answered yet, right? I would say CESAM framework is more it breezes functional decomposition. There is no before then allocating the functions to components. You can have functions that are not not in an object, not in a component, which is my understanding of. I'm not a specialist of the object-oriented approach, but I would say it's more a functional decomposition approach. But I'm quite sure it's compatible with not many changes to an object-oriented approach.
Okay, does that answer your question, John? If you want to unmute briefly.
To some degree, this is a kind of a major challenge that I see in systems engineering right now, because software people are all object-oriented, and most of the work is in software, and much of what comprises a system is in software. And so functional decomposition is actually not very intuitive. And so by embracing functional decomposition, systems engineering is creating an island when we're supposed to not be an island, but a unifier. And so extremely problematic. So when I'm teaching actually modeling and simulation and the rest, I actually am happy when my students don't know any systems engineering, because then I can teach object orientation and they don't get confused. So I see the challenge that you face, because very strangely, SysML is very object-oriented, but then we try to use it in a functional decomposition way and call it an object-oriented, and it just frankly isn't. So I can see in your framework it's a challenge, because you really want to support both of those views. And finding a path forward for this, I think, is going to be important for the discipline. So thank you, Sebag.
Thanks for your question. Very interesting.
Okay, perfect. So I'll mark that as answer live. And the next question, is the constructional layer equivalent to a bill of materials?
You want Cecilia, or should I?
What do you mean by bill of material? You mean the list of material, the detailed list of material to manufacture the system, for example? The bill of quantity?
I would imagine so.
Okay.
Yes, the detailed list.
So.
Yes,
Okay, so I think it's more high level than that, because you have several layers of breakdown on the constructional layer. So first you start with the high level, then the first types of components, then you can break down each component into subcomponents. And of course, the final result of this decomposition or breakdown will be at the
Oops, we lost connection there.
We lost, right? Oh no.
But you have to ask yourself each time you.
Cecile, sometimes you're cut for a couple of seconds.
Yeah, we lost you for the last 10 seconds, probably.
Okay, so I was saying that the idea is here, but a bill of quantity will be like very detailed, and it will be the last step of breakdown in PBS, for example. So that's not the main purpose of the constructional layer, I think. but that can be one input of how to build the bill of quantity.
Okay, perfect. Thank you. The next question, how do you represent a logical architecture?
Okay, I will take this one. So the first disclaimer is to make sure what we define behind the logical. So I know that sometimes it has a functional definition in the Capella framework, for instance. I don't know if it's the Capella one, but sometimes it only means abstract components, but it's really the boundary between a component and its function. You know, I guess you know that. So the per default one is to say that we take the constructional layer, and it has a certain level of maturity, which is that components are abstract. We don't choose yet the implementation. There are two levels of abstraction of component. Let's say an engine, and then you choose the type of engine, etc. So it would be basically by the construction layer, keeping components abstract, and then let's say your project evolves and you choose your actual components. If it's the Capella one, which embeds also functions, then it's a mix of functional layer and construction layer. It really depends on the definition.
Yeah, thank you very much. And then last one that we have in the Q&A is, how are you implementing simulation processes in tools like Capella, Cameo, or Magic Draw?
This one is for you, Cédric.
We're in touch with customers who are simulating, let's say, basic system simulation for consistency of states, checking the consistency of the architecture, but we haven't yet, let's say, connected directly the framework with simulation capabilities. I would say it's really, we represent the framework in the model. So I don't know, a block will be for components, just saying with a stereotype, whatever. And then the people will say, how do they simulate? But we didn't do a direct bridge. So we are not really implementing in some way.
Okay. And there is a new question that just appeared. I have a friend doing a master's and looking to specialize on MBSc. Now is looking for some hands-on experience as internship or some research approach. Who from CESAM could she get in contact with to find some collaboration opportunity? Doing some networking here. Okay, maybe. Sorry, go ahead.
She can of course contact us, and we will see if we have opportunity. But I don't think right now we have an opportunity as internship and research subject, but let me check. Okay, you can just contact us.
So you,
Cécile? Yeah.
Yeah. Do we put an email address, academy, or
contact at CESAM.net?
Yeah.
Okay. Very good. Thank you. And then I believe we have a couple of extra questions in the chat. So some of them were already answered by Cécile.
I'll try to, but it was too fast.
Yes, I'll focus on the ones that are still unanswered. So question from Misael. The CESAM framework, is there a recommended approach or standard for requirement writings? For example, IERS.
Yes, we provide templates to write down what we consider as good requirements. For example, for the need, it's always from the stakeholder point of view, and we always associate a need with performance, so it can be verified easily, and then with a context. And we have the same kind of templates for functional requirements and constructional requirements. So we always in these templates associate the needs with some satisfaction criteria, for example, and a category. So we can categorize and organize, and we say architecture, the needs and requirements. But you will find that, I think, in the takeaways if you want to download them.
Thank you.
Yeah. Yeah, to add, I was looking at EARS. There are of course some very common things like that Cécile just described, and maybe for those who know, we are really on the who, what, how well, and when. And then, for instance, EARS provides more, subcases or more details, but the basic is clear: who, when, what, how well. Sorry, for questions that apply in the 3 layers. But yeah, the answer was already good from Cécile.
Perfect. Understood. Thank you. So the next one, John's question we already answered. So the next one is, are you familiar with the CAFCR framework from INCOSE fellow Mr. Gary Mueller? It consists also of a limited amount of views, 5, typically also connecting why, what, and how.
Myself,
I was looking, yeah.
Okay.
But there's a lot of framework existing, each one with their advantage and inconvenience. But we do not pretend to know every framework, of course.
Right.
That would be interesting if that person has some information about that framework. You can share it with us, so we can have a look.
So if the person that posted that question wants to add any further detail, you're welcome to do so. If not,
but basically, what I think Sebag has already mentioned in this presentation is that we can make some links with CESAM, between CESAM framework and some other architectural framework, between CESAM framework and NAV framework, between CESAM framework and Arcadia, and so on. So I'm sure
the next question.
we will find some links between this framework and CESAM framework.
right. So he posted a link in the chat, so we can review it later.
We'll review it. Thank you for sharing.
Thank you. Okay, that was the last question, if I'm not wrong. So we still have 9 minutes, so I will take my freedom as the host to ask the last question if nobody has any other. So one question, do you have any experience applying the framework to brownfield system? So any kind of legacy system that originally wasn't properly documented, there is no the baseline system model, and then it has to undergo a major modernization or upgrade project, right? So
yes,
the way to tackle the problem from an embassy perspective is different, because you probably, the operational needs are captured somewhere in a document, but right there is no really a model providing a baseline for that. So if you can tell your experience working with clients, if you have done something similar.
Yes, I was even going to try to open the slides because, well, the challenge in this case, we always say that we need to start by having, let's say, an efficient, let's say, a just necessary description of the legacy system, because we can't really, be blind and look at the target without looking at the legacy. We have a simple impact analysis method, let's say, but that is very logical. And indeed, the more we go, and even when we train people on top-down approach, so they really go from the needs to the system, it's really for them to go through the process. But actually, they almost never do, not brownfield. I don't know if it's greenfield. Yeah. So they always have to use it to an existing system. And we have a couple of, we describe the existing. We try to find the impacts of the new needs. So you need to be able to compare the needs, existing, future needs. Then you say, okay, what are all the consequences of these gaps? So if I change this component, what happens to the neighbors? What happens to my consistency of requirements? So we follow a step-by-step impact analysis to gradually see if we can architect a consistent system based on that legacy. Maybe if you want to add something, Cécile. Yeah.
Is it a requirement? Is it a requirement, right, to reproduce every step of the framework? No. It's virtually impossible sometimes, right? So
that's why
the gap analysis or the impact analysis that you mentioned informs the steps that you're gonna actually execute. Right?
Yeah, that's where it's good that architecture or a model never replaces collective intelligence, let's say, to really together trying to see, okay, I think we need to do this. Another, the mechanical guy will say, I think I see this impact, the thermal guy. And so depending on, you know, of course, there's always a risk, because if you've not done the study, there's always a risk that you're not 100% confident, but it's how it should be. And then you can say, okay, we really need to go on, you know, to do a scenario, we need to start with a constructional scenario. I don't know. There's no, you know, we don't need to do this. We need to start with that and this, because that's where we're going to see really the impact, let's say.
Okay.
And yeah, that's an example. Yeah.
Okay, very good. Thank you very much. Cecile, you wanted to add something, or I think I interrupt you?
No.
Okay.
No.
Okay, and we have a new question related to Agile. So I guess the question is how to deploy Agile in a, let's say, Agile framework requirements. I guess if you have an analog of this approach in an Agile format, is something that you have done in the past?
Agile,
Sorry, yeah, Agile.
Agile, okay. Yes, of course, we can apply the methodology to Agile projects, because the principles are the same. It's just the way you orchestrate the principle that change in this type of project. So first, what we say is first have a model of the product you want to build, okay? Because it will be like your product roadmap of where you want to go, agilely speaking. And then you define key design drivers, okay? That allows you to plan a gradual maturity increase, okay? Based on the product, the modelization of the product you have first. So with the modelization of the product, this key design driver, you repeat the methodology several times in order to increase each time the maturity, okay? And at each maturity increase, well, you check that you have reached what you wanted to reach, okay? So you can see the framework as a way to put some borders in the agile way to implement it. I don't know if you want to add something, like
maybe. No, I'm kidding. Yes, it's true that we will tend to use, let's say, adjusted, not the 15 views that I showed, but mostly the central views and the needs and the product breakdown, the key design drivers, which is usually the name in this case that Cecile mentioned. And basically you want, and really the agile is on the right. It's about how you're going to work. The target system is on the left. It's really the approach we already saw. And then it's about who does what, how do we organize in iterative loops, and what do we synchronize? And the key thing is about knowing the maturity, because if you do a detailed design that you're still in an early phase, you waste your time. So they are perfectly matchable. And it's true that people think they're contradictory, that architecture means rigidity and agile means freedom, but it's really taking the benefit of both. So yeah, I just wanted to show this little sketch.
Good, agree. Thank you very much. And with that, I believe that was the last question. So I think we are 3 minutes away on time to close the webinar. So just to reiterate, thank you very much for this presentation. We really appreciate all the good information and all the material that you have shared with the community. And we look forward to having you again in the future, maybe with another presentation. So let's stay in touch.
It's a pleasure.
It's a pleasure. Thank you very much. Thank you for your questions.
Thanks to all the participants also. So we'll stay in touch. Bye-bye.
Thank you.
Thank you, Cecile. Thank you, Sebag.
Thank you. Thank you, everyone.